This video clip explains how to solve equations with variables on both sides of the equation. You've done that before. We're just going to come up with a new story problem to keep practicing that same idea. Suppose you have a taxi company that charges $6 to get in the cab and 60 cents each mile that you go. And taxi company B charges $2 to get into the cab and $1 for each mile. So if we were to write the cost of one company, that would be $6 plus 60 cents per mile. If I drive long enough, that will be equal to the other company, which is $2 plus $1 per mile. Now, if those are in dollars, then $1 is 1 and 60 cents is 0.6. 0.60 is acceptable also. Now we just have an equation with variables on both sides. I usually leave the largest term where it is, $1 per mile. Let's subtract the 60 cents per mile from each side. 60 cents per mile, subtract 60 cents per mile is 0. 6 plus 0 is 6. $1 per mile, subtract 60 cents per mile is 40 cents per mile. Now we want to solve for m, the number of miles that it would take for this equation to be equal, to be true. Let's get rid of the $2. So it just says the difference between the two companies, so $4, is equal to the difference in their mileage rates, which is 40 cents per mile, times the number of miles. We do the opposite of multiply by 0.4. We divide by 0.4. 0.4 divided by 0.4 is 1. 1 times m is m. 4 divided by 0.4, well, you can see that 4 is 10 times bigger than 0.4. You can put that in your calculator if you want. The decimal place is only over 1 to the left on the bottom, so the top is 10 times bigger. So the answer to that equation with variables on both sides is 10 miles. Maybe we should try another example. This taxi company charges $8 plus 75 cents per mile. And at some point that will be equal to the other company, which charges $3 per mile plus $1.25. $3 plus $1.25 per mile. Let's subtract the smaller m term. 75 cents per mile is smaller than $1.25 per mile. $1.25 minus 75 cents is 50 cents per mile. So $8 is equal to $3 plus 50 cents per mile. That value of m would make the original equation true. Let's whittle it down a little more. Subtract 3 from each side. So 5 equals 0 plus 50 cents per mile, or just 50 cents per mile. And then we divide by 50 cents, or half a dollar, divided by 1/2, divided by 0.5. So the number of miles for this case also equals 10 miles. I might just point out that on the computer, these will not always be whole numbers, but since the answers only have to be within 5%, if you choose the closest mile, they should all be fine. You can put decimals if you want.